going to take a look at remainder theorem. We know what a polynomial is. Remainder theorem tells us that when a polynomial is divided by a linear divisor in the form x minus a, the remainder is going to be the function of a. We are going to prove this today. Firstly, let's consider this 2x to the power 4 minus 3x to the x cube plus x square plus 1 as a polynomial. This is being equated to with this identity sign to x minus 2 and 2x cube plus x square plus 3x plus 6 plus 13. Now the terms that we have on the right hand side of this sign, these are known as, the first is the divisor, the second biggest term is the quotient, which is being multiplied with the divisor, and the last term, which is 13, is the remainder. We had the polynomial, which is 2x to the power 4 minus 3x cube plus x square plus 1, and this polynomial is equals to the divisor of this polynomial, and when we divide this polynomial with this divisor, we get the quotient. So divisor multiplied by quotient, and the remainder that we get is the big, and adding the remainder, we get the dividend, which is the polynomial itself. This process is very lengthy. It is known as the long division, which is also not included in our syllabus. We're going to look at a shorter method of determining any factor of the polynomial, and we are also going to determine the remainder, which is the leftover after the polynomial is being divided by that particular factor. First, let's take this first let's see this, which is in general terms. F of x is equals to x minus a, with x minus a is basically the divisor, which is x minus 2, and then we have the quotient of x plus the remainder. If we are going to substitute the value of a in place of x, we get the remainder. How do we get that? Let's see. In this over here, we are substituting x with a. So f of a is equals to a minus a automatically becomes 0 regardless of what number a is. When this 0 term is going to be multiplied with this quotient of a, this whole term is going to become 0, and we are only going to be left with positive remainder. So that automatically tells us that the function in terms of a, which means when we are going to substitute x with a, we are going to get the remainder. Now let's look at an example of doing this. We have this question. F of x is equals to 4x cubed minus 5x plus 1. We need to find the remainder if it is divided by x minus 2. See that x minus 2 is in the form x minus a. Now, what we are going to do is, in order to get the value of x, we are going to equate this expression to 0. Why were we doing this equation to 0? We are going to equate this to 0 because when you see over here, we are basically going to make this first whole term 0 so that we're only left with r, and we can find the remainder as it is mentioned over here. So we are going to equate this. In order to equate this to 0, we're going to equate x minus 2 to 0, and we get the value of x as 2. Then we're going to replace every value of every x with 2, and we get this expression, this whole expression, which is automatically equated to r. When we solve this with mathematical addition and subtraction, and multiplication, we are going to get 23, and 23 will be our remainder. This is one of the shortest ways of finding the remainder, and this automatically implies that x minus 2 is not a factor of this polynomial because it leaves a remainder. If it had been a factor, then the remainder here would be 0,